Imagine you walk into a candy shop with $120 in your pocket. The shop sells two types of candy: 1 ounce of chocolate bars for $5 each, and 1 ounce of gummies for $3 each. You decide to buy a mix of both, but want to use exactly $120. How many chocolate bars and gummy packs can you buy? If we let X be the number of ounces chocolate bars and Y be the number of ounces of gummies, we can set up the equation. 5x plus 3y equals 120. This equation represents a linear equation in two variables. Every pair x, y that satisfies this equation is a valid way to spend your money on candies. Note that the highest exponent of the variables is 1. We can also write the equation as y equals 120 minus 5x divided by 3. Let's try to substitute values of x and get the values of y. Thus, we get this graph, which is a straight line. In coordinate geometry, the equation of a straight line is represented by such linear equation. Now, let's say that you have another constraint. You can only carry 30 ounces of candy in your bag. This leads us to another linear equation in two variables, x plus y equals 30. Thus, we have two equations and two unknowns. This implies that there might be a unique solution that satisfies both the criteria simultaneously. Let's try to substitute y in terms of x in the first equation and solve for x as we did in our equations tutorial. We do simple algebraic operations to get the x terms on the LHS and rest of the constant terms on the RHS. We get x equals 15 ounces. When we substitute x back in the second equation, we get y equals 15 ounces as well. Thus, we have a unique solution to the system of linear equations. When solving a system of linear equations, there are three possible cases. When a1 over a2 is not equal to b1 over b2, we get a pair of intersecting lines. When a1 over a2 is equal to b1 over b2, but is not equal to c1 over c2, we get a pair of parallel lines. When a1 over a2 is equal to b1 over b2 is equal to c1 over c2, we get coincident lines. A system of linear equations is considered consistent if it has at least one solution, meaning there's at least one set of values for the variables that satisfies all equations in the system. Unique solution: the lines intersect at a single point, and this point is a solution to the system of equations. Hence, it's consistent. No solution: the lines are parallel and never meet. Hence, it's inconsistent. Infinite solutions: the lines are identical, meaning they overlap completely. Hence, it's consistent as infinite solution exists. There are three methods to solve linear equations. Substitution: this method works by solving one equation for one variable and substituting it into the other equation. We first solve the first equation for y in terms of x. Now we substitute x in the second equation. Substituting x equals 1 back into y equals 3 minus 2x, we get y equals 1. Elimination: this method eliminates one variable by adding or subtracting equations. We multiply the second equation by 2 to align the coefficients of x. Now we subtract the first equation from second equation. We get y equals 5. Now we substitute the value of y in second equation to get x equals 3. Cross multiplication trick. This is a direct way to solve a system of two linear equations in two variables. It follows a visual structure, making it easy to remember. Please note that all the terms of the equation should be on one side of the equality, and other side should be 0 before extracting out the coefficients. Write the coefficient of x, y, and the constant term in the format as shown. Now we're going to cross multiply the values and write it as shown. X over b1 c2 minus b2 c1 minus y over a1 c2 minus a2 c1 and 1 over a1 b2 minus a2 b1. Let's solve an example using this method. First, we will take all the terms to one side of the equality. Then we will write the coefficients as demonstrated earlier. Finally, we obtain x equals 3 and y equals 4. Thank you for watching. Please stay tuned and don't forget to like, subscribe, and share.